Okay, so today is called 4.7 worksheet number 3, and it is about like 3 or 4 major concepts in trading. The first one is about graphing inverses. And so to get graphing inverses, we need to go back to what about graphing regular ones. When we graphed sine, there were 4 major marks like this. Every mark was always how far? Pi over 2. Still is. Now, if I want to graph the inverse of sine, I want to remind you that we only considered this part between here and here, which is between negative pi over 2 and pi over 2. This little part of sine can have an inverse. Because remember, to have an inverse, it has to pass both the vertical and the horizontal line tests. And so this one, the little green zone here, will pass the vertical and horizontal line tests. So then, this is the other part that gets weird though. It used to go from pi over 2 to negative pi over 2. And it used to go from a maximum right there where the highest spot was 1, and the lowest spot was negative 1. Now, when you do an inverse of a graph, do you remember that you reverse your domain and your range around? So if the normal domain and range for sine, all I've done right now is graph sine. I'm just kind of zeroing in on one little part of it. Domain and range for sine, domain is negative infinity to positive infinity, and the range for sine is from negative 1 to 1. Oops, I can touch negative 1, and I can touch 1. Can't never get to infinity. Okay, there we go. Do you get that that's domain and range sine? All right, did you have a question? I agree with you. If we would have chosen this from this place to this place, it would have been just as good. It also works. But basically, for simplicity's sake, you pick the spot that's closest to the origin. And it's an artificial limitation to make it work so it will have an inverse. But if we just say that, oh, sine can have an inverse anywhere, it's not really true. Like for this little zone here, it wouldn't work because wouldn't pass the horizontal line test in that little zone. So we picked this zone between the blue lines for it. All right. So now, one of the questions on a test could be as simple as this. What is the domain and range of inverse sine? What's the sine? So what would inverse sine's domain and range be? Just reverse it. Y equals sine with the little negative 1 of x. You just reverse it. Domain and range, whatever the domain was, becomes the range. Negative infinity, positive. And whatever the range was becomes the domain. Negative 1 to 1. Do you get how you can reverse those two? Okay, so whenever you're doing an inverse, you just take the domain and range of the parent one and flip it. Okay. The graph, however, actually making the picture is the harder part. I'm going to make the picture below this one. I'm going to make you a picture for the parent graph of inverse sine. Y equals sine with a little negative 1 of x. And where normal sine goes like that, we have to reflect it across this line right there. And so inverse sine is this green one. Do you get that? And here's the really messed up part. Its domain and range are right here. So the domain says it goes from negative 1 to 1. I know that's where it seems like that's where pi over 2 is supposed to be, but it's not anymore. Not on inverse sine. And the range for inverse sine is not limited, which means that this has to keep going down and this has to keep going up. Now it goes from negative infinity to positive infinity, and it goes from negative 1. Get that? All right. Cosine, even more tricky. The first part's easy. Cosine, graph cosine like normal, and makes like a valley shape. Okay, 4 marks. 1, 2, 3, 4. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay. But only part of this that's closest to the origin will pass the vertical and horizontal line test, the part between here and here. So I don't need this other part of my graph, so I'm just going to erase it. I'm only caring about the parts between the dotted lines there. And how do I get the inverse of that? Same deal, got to flip it over the y equals x line, which is right there. And my new answer will look something like this. The old one went through 0, 1, which is right there. So therefore, this one has to have a spot just like that, except down here. Okay. The old one went through pi over 2, or 0, pi over 2, so this one, or sorry, pi over 2, 0, so this would be 0, pi over 2, which should be like up about here. So it's going to start down here, go through here. That is a flip across this line. So if I want to draw it in the same direction, something like this. The green one and the black one are flips of each other. I don't think we will ever ask you to graph that on the test because it's hard. It's even hard for me to do, and I've done it many times. It's really hard to picture flipping across this dotted line here. It gets pinned at this spot. That spot doesn't move. Everything else has to like rotate around. It's really hard to. On the red one, I don't like the blue. I think I'm going to stick with the one. Think so? It is a reflection. I think it's right. And I know it's hard. It really is. It's tricky. Okay. So, but what would I ask you on a test? What I would ask you on a test is, what is the domain and range of inverse cosine? So it really, you should ask yourself in first, what is the domain and range of cosine? Because as soon as you know that, its domain and range will tell you the domain and range of the inverse. They just get reversed. So a normal cosine is the green one up here. I'll draw over it in red. That's normal cosine. It has no limit domain, and on the range it always goes the same deal. It starts at -1, goes to 1, same as last time. So you reverse it, and you got your domain and range of inverse cosine. Time to take turns. Okay. And now, tangents. All right. Here's the easy part. The part you probably be tested on. What's the domain and range of inverse tangent? Well, what's the domain and range of tangent? And then I'll reverse it. Normal tangent has all that beautiful symmetry. Remember how normal tangent looks like this? What's its domain? It doesn't go forever. It goes between here and here, which is between what? -pi/2 to what? Pi/2. So what's, now wait a minute, and what's the range of this? Is there any limit? No limit. -infinity to positive. So then, and will it actually touch this? So then, the inverse tangent has a domain and a range that are reversed of that. The domain becomes the range, or the range becomes the domain. So if I want my domain, I look at my range here, positive infinity. If I want my range here, I look at the domain there, -pi/2 to pi/2. Whew, here we go. That's the first 1/3 of what I need to teach you. There's 3 parts to it. First part is just how do you find the domain and range of inverse tangent, or cosine, or sine. And you just find the domain and range of the parent one, or the normal one, the not inverse one, and then flip them. Okay, what's the next thing I have to teach you? Question on the last one? What does the graph of tangent's inverse look like? Again, I don't think that's something I would test you on, but if I had to flip this across the line y equals x, okay, then I'm going to take this part and it will go, make sure I get this right. It'll go like that. Nope, 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 nope. Yep. There. Okay. And then this other part here, this part that I will temporarily make black, part there, that part there, has to go like that. Okay, now think about this. Do you get how the range on this thing is limited? It's limited to between something and something. See how there's an asymptote like here and here on my new graph? And do you get that its domain goes on forever all of a sudden? And see, it goes forever this way, goes forever that way. So there. That's what its picture would look like. But again, not something I'm thinking I'm asking you, but I am going to be asking you these two, which are, how do you just take the parent one, the normal one, and reverse it? Okay. Now, just a side note, if I had this, and let's make it something other number than 3, like that 1, do you get that that one's going to move 1 to the left and up to, and get stretched 3 times as tall? Okay. So it's the same exact thing if I had an inverse sine of that. Same kind of rules. This is going to move the whole graph up 2 spots. And it's going to make the whole graph 3 times as tall. If I wanted to move the whole graph to the right like 7, I could go like this. Get what I'm saying? Still follows all the same rules on that. Okay. So wait a minute though. What if I move it like just to the right side? Keep it simple. And then I say, now what's its domain and range? Well, first of all, I got to know what original signs domain and range are. Original signs domain and range. Domain, negative infinity, positive infinity. Range, -1 to 1. Brackets, parentheses. Okay. Then I would change it to inverse sine. Inverse sine's domain and range are reversed of that. So domain becomes this part, and the range becomes this part. Following me so far? And now, what if I did this though? I just moved it where? To the right. How far? 7 spots. Do you see how that's going to affect the domain? Because that's like a left-right thing. Now my domain, which used to be right here on the graph between there and there, I got to move it all over 7 spots that way. Both of these. +6 to positive. I'm moving over 7 spots. Between 6 and 8. All right. That's the first major thing to learn. Next major thing, we can fit through this before lunch, and then we'll only have one thing after this. Next major thing is if you're solving equations that have... Okay, here's yesterday. Yesterday you had this, and I would have said like 1 over root 2, and then you'd have been able to set me up a new problem that was like this. Sine of theta is equal to 1 over root 2. And then you could have drawn a triangle, and you could figure out what angle that is. Okay? All right. Or let's say, even more likely, it would have been like this one. Or was this 1 over root 2? That was possible. That was good enough. I'll leave it about that. Okay. So yeah, the answer comes out to be, I believe, 45, right? Okay. So then, the next step was, what if you do like cosine of that? Well, then the problem just was start in the middle, do the middle one, get done with that. And if the answer is pi over 4, now I do cosine of pi over 4. Okay? Do you get how we made them twice as hard because you had to do the middle first and then get done with that and then do the outside. Okay, now we're going to add one more way we can make them harder. They're double like this, where they have an inside and an outside. And now they don't tell you what the sides are at all, they just say x. the side is just x. X over 1. Then, let's just draw for a second. Here's a triangle. Do you get how I can make one of these sides x and one of these sides 1? So if I'm going to make this sine, and it's sine where x is the opposite over hypotenuse, the opposite, so it's like the sine of theta equals x over 1. Opposite is x, and the 1 is the hypotenuse. Then I've got opposite side from this angle is x, and the hypotenuse is 1. Do you figure I can figure that side out using the square root? Let's just take a second to figure that out. This could have been a problem you could have been given in like 8th grade in geometry. They could have just said, here's a triangle, it's a right triangle, and this side is x. And this side is, sometimes it's not 1, sometimes it's like 3, or sometimes that's 3x. But let's say it's x, and let's say that's 1. Then you can figure out this must be the square root of something. It's always the square root. And then you'd take this squared, and what would you do with that squared? Subtract. You go 1 squared minus x squared in this case. There we go. What if it's the other way? What if this is x and this is 1? You don't assume, oh, it must be a 45-degree angle. You don't know that. This is the square root, right? And what would it be? X squared minus 1. Squared. And 1 squared is 1. So, I take it that way. All right. And how about this? What if it's like this? And this is 2x. And this is 1. It's always a square root, and then what? 2x squared plus 1, and it's so painfully close to right, but it's not. The 2x squared part is messed up. Yes. This part here has to, the whole thing has to get squared, not just the x. So 2 squared and the x squared makes this 4x squared. Unless you had written it like this, then I could have taken it. Because that means 4x squared. All right, one more like that. This time, everybody try this one. This one's going to be 3x. That one's going to be 1. Don't say it. Figure out what this other side is. It's crucial. Crucial skill for you. I know there's a lot of noise, but technically I'm not supposed to let you out for 4 more minutes, but I'm going to let you out earlier than that. Just a bunch of knuckleheads. All right, square root of 9x squared plus 1. All right, good. So, and yes, nope, but yes, it could have been parentheses 3x, just quantity squared. Okay, so now let's go back to this problem that I gave you originally and said this is the kind you're going to have to answer. You'll see it's not as scary as you might think. So I don't give you the sides, but I give you an x. Then I draw myself a little triangle. And I say, sine is opposite of hypotenuse, opposite x, angle here. And by the way, you don't have to worry about what quadrant to put it in either, just make a nice triangle. Because I haven't told you if x is positive or negative, and so you can't like figure out where it is. But this side's x, hypotenuse is 1. This one's square root of what? 1 squared, which is 1 minus x squared. And then, if I want to do the cosine of that angle, even though I don't know what the angle is, if I want the cosine of it, remember how the triangle's already drawn for me, and I never had to like go redraw the triangle? I already have the triangle. So cosine in that triangle would be adjacent over hypotenuse. That would be that over that. And therefore my final answer is square root of 1 minus x squared over 1. Just sit down. Oh, okay. Trying to like just like walk out. Okay, very soon though. Okay, so final answer would have just been this. Key skills, if I just give you an x and on another side is like a 1, you got to find the third side, which always is the square root. And then also, don't ever try to figure out the angle is like 45. You don't care. You just want the cosine of that angle. So in the end, you're just going to have this new number that you made and on one of the other sides. That'll be it. All right, lunchtime. Okay, so I'm back from lunch, and I want to actually start the last type of problem that you need to know how to do. All right, on this type of problem, you're going to be given a equation that has an inverse sign and a sine, and you're going to be really tempted to just go, oh, those always cancel each other out. They don't always cancel each other out. Okay, and you're going to need to check yourself carefully before you cancel things. So here's what you do. Wait a minute, this one is equal to 1. All right, so on this problem, what you can do safely, I think I explained this one before, is if you want to add an inverse, or sorry, a sine to both sides, take the sine of both sides, sine of this side, and you can take the sine of that side. You can do that. And then when you just did that, when you take the sine of the inverse sine, then these two will cancel. Okay, that's okay. Then you can look at this and make sure this is really true. That, what does x have to be, logically? X equals 1. Why am I putting you through this? Why can't you just cancel off these two? And then say that the answer is x. Because there's a lot of problems, like including on last night's homework, where when you do it from the inside out, you don't get this answer. You get a different answer. But that's if there's a degree there. Like if there's like a 30 degrees or a pi over 6 or something. Then it can come out that you can't just cancel these two things. All right. So, moral of the story on a typical problem like, here, I'll hand this out and we'll do number 8 together. Or number 9, anyway. Here we go. Just bear with me for a second to get this handed out. There's 2 in here for your row, too. Okay. Well, let's actually just attack these one at a time, because you're probably going to notice problem number 1 first on the worksheet. Let's do problem number 1 off the worksheet. Again, the worksheet is 4.7, number 3. And the first question is inverse sine of x. And it says f of x equals, I'm going to put y equals, means basically the same thing. And now, sketch a graph and analyze each function for domain and range. All right, the quick sketch of the graph means start by graphing sine, but really only graph this part of sine. And then remember, the inverse is where you take that, which is normal sine, and you flip it across this line, so you get that. So the red one would be your actual answer. The other one is just kind of helping you to construct it. And do you remember how to get domain and range of inverse sine? Flip the domain and range of regular sine. So if I take regular sine's domain and range, then regular sine's domain is negative infinity to positive infinity, and its range is normally from -1 to 1. That part should be easy for you. Look a little picture of it if you have trouble with this reference. But now, it's scary. Great. Alright, so here's regular sine. And domain and range are negative infinity, positive infinity, based on that picture. Okay, so then what are the domain and range of this guy? Domain, range. I just take these others and drag them down. Like this domain has to become that range. And this range has to become that domain. There we go. That's how I do this. The pictures, I did give you a sketch in your notes for cosine. You can copy the sketch that you made in my notes for problem number 2. Problem number 3 is tangent. I gave you a sketch for that too. If you have the notes, you got your sketch. I wouldn't focus that much on how those graphs look, because it's not often that anybody, again, calc, they'll totally expect you to remember what sine looks like, cosine looks like, but they're not going to really be like, oh, of course you remember the graph of inverse sine. But what they would expect is that it wouldn't be hard at all for you to know what its domain and range are, because you just take the domain and range of regular sine and reverse them. Okay, let's move on to problem number 4. Let's do one like that. It says inverse sine of 2x. And what does it want to know? It wants to know if you were going to shift this thing this way, would it make it twice as wide or half as wide? That's half as wide. So that's the first thing you got to do is just tell what would happen. So you go half as wide. And then you have to make the domain and range of this new function. Okay, so the domain and the range, we just got done with this like 2 seconds ago. The domain and range of sine just get reversed. So what the domain of sine, which was negative infinity to positive infinity, goes here. And the range of sine, which is negative 1 to 1, goes here. But, now this is the hard part, it's half as wide. This one is all about the width. So that's when we got to change. And it now has to be half as wide. So instead of going all the way over to 1, now it's only going to go over to a half. And instead of going all the way to negative 1, it's only going to go to negative a half, exactly. Negative a half to a half. So my domain just got half as wide as it used to. You get? Okay. Let's move on to the next kind, which is problem number 8. But I've already done that with you. You may cross that one off. Let's do number 10, for instance. Okay. Number 10. It says 2 inverse sine of x is equal to 1. My first thought is that 2 seems out of place. Can I get rid of it? Sure, swap it. Swap it. And then I have inverse sine of x is 1/2. That still seems a little backwards. When we did our inverse sines, didn't we normally have the sides here? And then the angle was on the other side? It's like backwards from normal. What did I tell you you could do to both sides? Oh, go ahead. You got it. You can reverse this now. You rewrite this, and sine of what we usually just call theta, but now we're reversing. This is going to go in here. Is equal to x. That should be true. Now, this is supposed to be an angle. Now, it might mess with your head a little bit. Is it 1/2 of a degree? No, that it had to label it as degrees. It's half of, well, what? It's half of a radian. Normally, our radians have pi in them, but do they have to have a pi in them? Nope. It could just be 2 radians. All right. So how do I finish this? I'm trying to figure out what x is. Wait a minute. I just got x alone. Didn't I? Isn't the point to solve for x? Yay. Just figured it out. X is alone. That's the answer. But maybe you should know what sine of 1/2 is. Sine of a half of a radian? What does that mean? Okay. So is the final answer for this thing, would it be sides or would it be an angle? It would actually be sides. Does it say an angle for this one? No. It says if the answer is an angle, the answer in radians. It doesn't say the answer is going to be an angle. This one's answer is not an angle. Because see, what's supposed to go right there on an inverse, that's supposed to be the sides right there. So this one got a little bit messed up, but bottom line, isn't x alone? I have got x alone. It's alone. It's done. So there's your answer. All right. You're not going to have many like that. That's not a big deal. Now let's try another one that's in that section so you can see they're not all crazy. Let's do like number 12. Cosine of inverse cosine of x is equal to 1/3. All right. There's a fast way and a slow way, and I actually like the slow way better. I'm going to take the inverse cosine of both sides. Inverse cosine of this side too. And then that'll cancel that. And now I can say that inverse cosine of x is equal to inverse cosine of 1/3. And by logic, what's the answer? X equals 1/3. Why am I going to that great length to get that? And couldn't I have just jumped to it right at the beginning? I don't want you to think that you can do those problems that are like this. Root 3 over 2. Problems like this that you can just go, oh, cancel, the answer to 3 over 2, because it often isn't. And the problems that are like that, you need to start on the inside and do the inside first. Get it done, then do sine of that. Sometimes they will cancel, but sometimes they won't. So just don't want you to think, oh, anytime I see two inverses, I'm just going to cancel them. You will then get half your problems wrong on the test. Okay, so what you can do is what I did. If you do that to both sides, then you can make these two guys cancel. And by logic, get your answer x equals 1/3. Okay, and let's do one last kind, which is like number 14. Number 14 says sine of tangent little negative what, also known as inverse tan, of x. And now, they normally have put sides in here. These are the sides. The sides are x and 1. So now I'm going to rewrite it as just the inside part here. Tangent, normal tangent of an angle, will be x over 1. And now I'm going to draw my picture. Tangent's opposite over adjacent, x, 1. So then what's this got to be? It's always the square root. X squared plus 1. And then from there, I got to do the sine of this triangle. No, sine of this angle. And the triangle's already drawn for me. So I just got to do sine of this angle right here. Opposite of hypotenuse, so therefore x over square root of x squared plus 1. There you go. That is getting pretty abstract. But it just means if you don't even know the sides in the triangle, you can still get the answer in terms of x. Okay. And then there's some review across the bottom, 20, 21, 22. All right. That's all I got for you for today.